Honors Pre-Calculus Final Exam Review, number 78. So we're asked to find this power of a complex number and write the answer in rectangular form. Now in the previous problem, we had 1 plus I to the 20th power. We could not reasonably FOIL all that out. This one you could almost reasonably FOIL it out since it's only third power, but you'd have to deal with these square root 2's, and that would sort of get messier and messier as you went along. So let's do that one in polar form because it'll be a little bit cleaner. So here is our rectangular form and our third power. So the first thing we're going to do is take our negative 5 square root 2 plus 5 square root 2i, and we're going to convert that to polar form. So to convert that to polar form, we're going to use our formulas r equals square root a squared plus b squared, and theta equals inverse tangent of b over a. So our a is negative 5 square root 2 and our b is 5 square root 2. So we're going to say this is r equals square root of negative 5 square root 2 squared plus 5 square root 2 squared. When we go to square each of these out, we can distribute the power over these two factors of this product. So we can say negative 5 squared is 25 times the square root and the squared cancel out, and I just have 2. Now over here I have 5 squared is 25 times my square root 2 squared is just 2. So I have 50 plus 50, which is square root of 100, and I'm gratified to find that I have a nice simple value for r. Now for my theta, I'm going to do inverse tangent of my b, which is 5 square root 2, over my a, which is negative 5 square root 2. Remember, none of these formulas have an I in them because b is just 5 square root 2 and a is just negative 5 square root 2. So this is equal to the inverse tangent of negative 1. So to do the inverse tangent of negative 1, I need to think of my unit circle, and I need to think of my tangents on that circle. So my tangents go root 3 over 3, 1 root 3, and going down negative root 3 over 3, negative 1, and right here negative root 3. So I'm looking for the inverse tangent of negative 1, which occurs here. That's my negative 1, and that's also the angle negative pi over 4. So the inverse tangent of negative 1 is negative pi over 4. Now, I know that I can't have negative pi over 4 as my theta, just as in the previous problem when we were working in radians, the theta has to be between 0 and 2 pi, or when we were working with degrees, the theta had to be between 0 and 360. I know that the theta has to be between 0 and 2 pi. Also, I'm aware that this negative pi over 4 might be in the wrong quadrant. So now I need to look at a graphical representation, and we really can never get this theta right without looking at a graph of the complex number. And that graph is, we can find it by looking at negative 5 square root 2. Now I don't know exactly where negative 5 square root 2 is, but I'll just put it there somewhere. And then 5 square root 2i. I don't know where 5 square root 2i is, but I do know it's the same distance as here. So I have a nice 45-degree angle there, or a nice 3 pi over 4 angle. So here's my angle to my complex number. Here's the positive x-axis, and my theta has to be the angle with the positive x-axis. So if I look at the theta that I got from inverse tangent, it was negative pi over 4. That's down here. That's our negative pi over 4. But I'm not interested in this angle down here. I'm interested in this angle up here. So to get from this angle that I got from the inverse tangent up to this angle, I'm not going to add 2 pi. I'm not going to add 360. I'm going to add pi, or 180. So that means that I have to take my negative pi over 4 and add pi to it. And since pi is 4 pi over 4, that gives 3 pi over 4. So my real theta is 3 pi over 4, which doesn't surprise me when I'm looking at this angle and I realize it's a 45, 45, 90 triangle, and yet it's in the third quadrant. So I know that over here in the third quadrant at a 45-degree angle, that's 3 pi over 4. So I could have guessed from the graphical representation right away without even using the formula. I would have known that theta is 3 pi over 4. So now that we know the r and the theta, we can now write the complex number in trigonometric form. So my r cosine theta plus I sine theta, I'm going to write as 10 cosine 3 pi over 4 plus I sine 3 pi over 4. Now it's time to do, this is my polar form, but I haven't done anything besides take my rectangular form and change it into polar form. So now I need to do this. I need to do that third power. So to do the third power, I'm going to use de Moivre's theorem and do the third power of r and multiply the theta times 3. So what that will give me is 10 to the third power, which is 1,000, cosine, and I have to multiply the 3 pi over 4 times 3. So I'm going to have cosine of 9 pi over 4 plus I sine of 9 pi over 4. And now I just have to look at this and see, 9 pi over 4, that seems like an odd angle. Isn't that more than 2 pi? Because 8 pi over 4 would be 2 pi. I think 9 pi over 4 is more than 2 pi because 8 pi over 4 is 2 pi. So I'm going to have to get a coterminal angle by subtracting off 2 pi. And I might work off to the side that 9 pi over 4 minus 2 pi is the same as 9 pi over 4 minus 8 pi over 4, which is 1 pi over 4, or just pi over 4. So this is going to be my real theta at the end, and I'm going to say 1,000 cosine pi over 4 plus I sine pi over 4. Now that's my polar form answer, but the problem has asked me for rectangular form. So that means I must evaluate the cosine of pi over 4 and sine of pi over 4 and distribute the 1,000. So I'm going to have 1,000 times cosine of pi over 4, and hopefully we know our unit circle well enough that we know cosine of pi over 4 is square root 2 over 2, and sine of pi over 4 is square root 2 over 2. We distribute the 1,000, and hopefully you can see that the 1,000 is going to reduce with the 2 in both cases, leaving me with 500 square root 2 plus 500 square root 2i. So we are able to conclude that negative 5 square root 2 plus 5 square root 2i to the third power after all our work is equal to 500 square root 2 plus 500 square root 2i.